All right, so 1 second. Okay, this is the homework, right? Okay, so you can see the screen. Everyone can see my screen. All right. So okay, so before, so as I said in the group as well, we'll be doing focusing on the homework that was given last week. Is there any other question from the last class from anyone before we start?
No.
All right. Okay,
No
so the
question.
way okay, great. So we'll go about this worksheet, this homework, as we'll follow the same technique where I'll be engaging the class, all of you students as well. So we'll be solving these questions together, right? Okay, so here we have first question, and it says that the mass of a 35 centimeter cube. So this thing is volume, right? Of mercury is measured as this much grams. So this is the mass. Calculate the density of the mercury and give the unit. So we have to compute the density. So how do I do this problem? One of the things to understand was that this thing that is given is known as it is the volume, right? Because you can tell that by simply figuring out that this is measured in centimeters cube, right? So that's the unit for volume. So if this is given in centimeters cube and this is given in grams, we have to compute the density. So all right, so anyone from the class, how should I go about the problem?
We can use the formula mass over volume.
Right, so that's the expression for density, right? So
Mhm.
density is equal to mass over volume. So we're given the mass, right? And that's simply 476 grams divided by, this is the volume. So 35 centimeters cube. Now, if you do the math, this turns out to be 35 and 476, right? So it's almost 13.6, right? 13.6 grams per centimeters cube. Another way of writing this is 13.6 grams centimeter minus 3, right? So now, of course, you could give the answer in this way, or if I were doing, I could have converted from grams to kilograms, and I could have converted from centimeters cube to meters cube as well. But I mean, why make life hard, right? So you can just do this in, because we know that the units for density, they can be written as grams per centimeter cube, or they can be written as kilograms per meter cube. So these are the sensible units for writing density. So the correct answer would be 13.6 grams per centimeter cube. So that's clear with everyone, right?
Yes.
Okay, great. So this was for 4 marks, and these 4 marks were very simple to secure. All right, so let's go to the next part. And here we have that the density of water is much less than the density of mercury. So density of water is much less compared to the density of mercury. How does the mass of 35 centimeter cube of water compare with the mass of 35 centimeter cube of mercury? So how would you do this thing? So the key point in this is this sentence, right? Density of water is much less than the density of mercury. And what does density tells you? Density tells you how much of mass is packed in a given volume, right? So in a particular volume, how much of the mass can I pack in that volume, right? So if I can pack less mass, which means if density of water is less, so for water, I can pack less amount of water in a given volume compared to mercury. I can pack a lot of mercury in a small volume. That's what this sentence means, right? So we have to compare the mass of same amount of volume of water and mercury. So mass of water is less than the mass of mercury. Mass of water is same as the mass of mercury, or mass of water is greater than the mass of mercury. Which one do you think should be the correct option, given the understanding that I just said?
The first option.
Okay, so you're saying that the mass of water is less than the mass of mercury, right? So what would be your reasoning behind this option? Why would you say that it's this one?
Like you said, you can
Yeah.
compact more mercury in a lesser volume.
Exactly. So that's why this would imply that the water's mass is smaller compared to the mass of mercury. All right, great. Okay, so is that clear for everyone in the class?
Yes.
Okay, so everyone else agrees as well, right?
Yes.
Okay, good. So next we have the mercury in a thermometer expand when it's heated. So if you have, and we're all aware of that, right? That's how you measure your temperature if you're still using the mercury thermometers. It expands and it goes, the number increases. And so that's when you know you have a fever or something. So what happens to the mass of the mercury? So you have to understand that when mercury is going to, when you heat mercury, it's going to expand it. And it expands in this way that the molecules, when you heat it, it increases the kinetic energy of the molecules really. And then the mercury starts expanding because the atoms, the molecules, they are moving with higher velocities. And so they have the tendency to move further apart. And hence it expands, right? So what about the mass of the mercury? When you expand this, mass?
Because only the volume changes, not the mass.
Right, exactly. So and only the volume changes because we have density, which is mass per unit volume, and the density is going to remain constant, right? So
Yes.
or will it remain constant?
No,
or
the
no?
density would decrease when the thermometer expands.
Right, exactly, right, exactly, because it's going to expand, right? And so
Mercury
density would
expands.
start
When mercury
decreasing,
expands.
right? So because, yeah, exactly, because what is happening, the volume is increasing, right? So now there is more volume to pack that mass, and hence the total density would be falling down, and the density would be falling down, but mass is not going to change, right? Because the mercury is just expanding. So so a particular amount of molecules that were there, suppose that these were the molecules, right? Now when you heat it, the only thing that happens is that these molecules spread apart from each other, but the number of molecules, they still remain the same. So if I had 1 2 3 4 5, 1 2 3 4 5, but the distance between these molecules increases, right? But again, the molecules are still the same, right? So if the number of molecules or atoms of mercury are still the same, that means the mass is not going to change. So of course, the mass will stay the same. But the next problem is what happens to the density, and the density would decrease because of the fact that, for example, if I were talking about this much space of volume, right? So this volume, this is the volume that I'm talking about, where I just drew this box. Now, if I look at this box, the same box, when the molecules have expanded, I can clearly see there are less number of atoms in this box, right?
Teacher, can you scroll down?
Yeah, sorry, I'm at this point, I'm explaining this thing. You can see the screen?
Yes, but I cannot see the whole question.
Oh, right. So, well, it's the options are same, right? So decreases, stays the same, or increases in terms of density. And we have already established it would decrease, right? And as I'm just telling you why would it decrease. So is that clear for everyone in the class? Why would the density increase and why would the mass stay the same?
Could you explain the decreasing part again?
For the density, right?
Yeah.
Okay. Yeah. So basically think about this. We're just going to draw a visual picture, a random picture, right? So suppose you have, these are the atoms of mercury or molecules or of mercury, right? Suppose that these are spherical shaped, and this is just for our ease, right? So we have 1, 2, 3, 4, 5. Now this is the case without heating. So I'll just write without heating. I use abbreviations sometimes to write things. So this W/O means without. Now let's suppose that I heat this mercury. So when I heat it, what happens? Because heating the mercury just means that the atoms are going to jiggle around a bit more. Jiggling really implies they're going to start vibrating a bit more, and because of that heat they're going to gain some kinetic energy. So they're going to start it will be a kind of a chaotic motion, and what will happen is that the molecules will start moving apart from each other. So this is 1, this is the same 2, this is 3, 4, and 5. So these are the same molecules, right? The same as this one. But at this point, because of the heat, they have moved further apart from each other. So now let's do this thing. Because remember, density is the mass, the number of molecules, you can say, or the amount of stuff that is packed in a given volume. So suppose for understanding purposes, I'm going to draw a box that covers these atoms 3 and 4. At this point, you can see that in this box, there are 2 atoms, right? So this yellow part, right? There are 2 atoms or 2 molecules. Let's draw the exact same box. So it would be extending like this, like this, like this, and like this. So it's the exact same box down here now as well, of the same volume. Now you can see that in this volume, there is only 1 atom. So the amount of stuff that was packed has decreased now, right? Hence the density has decreased, because density is amount of stuff packed in a volume. So but this cube that I drew, this cube is like it's a
Can I
volume.
explain it better?
Yeah.
Can I explain it better? See, if the mercury is if mercury has a mass of like 5 grams, and the volume increases because of the temperature, then 5 divided by, then the volume is first without heating, the volume is 5 degrees, and after heating it is no, the volume is 5 centimeters cube. That after heating, it turns into 10 centimeter cube. Now, before it was mass divided by volume. It was
Right. Right.
5
So that
5
before
grams
the
divided
volume,
by 5
exactly,
divided
centimeters
by
cube, right? Yeah.
volume. Now the volume increases.
Exactly.
volume
Exactly.
increases.
I completely understand your point as well. You're using the mathematical formula to just put the values, and then we can check, and obviously we'll get a lower value for density, right? I was just trying to explain physically what's happening, right? So of course your understanding of the thing is also correct if you are talking in terms of the expression, right? So if I use a higher value of volume over here with the same mass, then the density would be a lower value. Or if I can use a value for volume which is lower, then the density would be higher, right? Because of fractions. So that's also completely, yes, that's also correct. but the physics of the situation, the physics behind what is happening is more or less this thing, right? So
I almost
you're
understand the physics.
yeah, okay, great. So everyone understands it in the class? Is it clear for everyone?
Yeah.
Okay, great. So all right. So is there anything that you would like to add more to this? I think Taha, you were speaking.
Teacher, your voice cut out for me.
Oh, you were speaking. I was just saying that if there's anything else that you would also like to add to this at this point, or we can continue.
We can continue.
Okay, great. All right, so that's this, and then let's move on to the next one. All right, so next we have another question, and here we have a brick, as you can see, and they're saying that there are 500 of these bricks, like the one shown in this figure, and they're stacked on a wooden platform known as a pallet. The pallet of bricks is to be loaded onto a lorry by means of forklift truck as shown. So what's happening is that you have this pallet which carries all these bricks, and it's kind of a rectangular shape, and on top of it you have all of these bricks placed in this order. Now each brick has a volume of 0.0012 meter cubes. So this volume is for this brick. So one brick, the volume is 0.002 meters cube. All right. And it's made up of a material of density this. So one brick, the density for just one brick is 2300 kilograms per meter cube. So that's the density for one brick. They're asking you to compute the mass of the brick, mass of one brick. So it's very simple, right? You will just use the expression. We have volume, we have density, and we are asked to find mass, right? Mass is unknown. So what expression relates all these three quantities? It is density, right? So density is mass per unit volume. So how much stuff is packed in a given volume? So just factor this expression for mass and you get density times volume. Next step is very simple. Just plug in the values. You get 2300 kilograms per meter cube times volume, which is 0.0012 meter cube. So meter cubes cancel with meter cubes, and doing the math, this gives you it gives you around about 2.8 kilograms, right? So the mass of, so this is the mass of one brick. At this point, we have only computed the mass of one brick. So is that clear for everyone? It was pretty simple, right?
Yes,
Yeah.
clear.
Okay, good. So now let's move on to the next part. They're saying that the forklift truck can safely lift a load of mass 2 tons. 2 tons is approximately 2000 kilograms. So they're saying that this truck, it can at maximum carry a mass of 2000 kilograms, including bricks and the mass of the pallet as well. So the maximum mass that it can carry and move without breaking is 2000 kilograms. Now, the wooden pallet has a mass of 100 kilograms. So this pallet on which all of these bricks are placed, right? It's like this, it's a rectangular pallet. On this, you can put all the bricks. So the mass of this itself is 100 kilograms. And on this, we are putting, they're saying calculate the total mass of the pallet and 500 bricks, right? So they're asking you the total mass of the pallet and as well as 500 of the bricks, where each brick weighs or has a mass of 2.8 kilograms. So how do I compute, first of all, the mass of 500 bricks? Anyone? sorry, mass of 500 bricks, right? So how do I compute the mass of 500 bricks?
Teacher, you multiply 2.8 by 500, it will give you the total mass of 500 bricks, and you add 100 kilogram because the pallet is the 500
Pallet, we
bricks.
also need the mass of the pallet, right? Exactly, right? So we'll, to find the mass of 500 bricks, we know that one brick weighs 2.8 kilograms. So I need a mass of 500 of them. So for one brick, I'll just multiply 1. For 2 bricks, I'll multiply 2. For 500 bricks, I'll just multiply 500. So this means that I'm just combining all of these bricks and then just finding the mass of all these bricks by just writing the mass of one brick and multiplying it with the total number of bricks that I have. So that's just 2.8 into 500, which would be approximately 1,480 kilograms.
No,
right?
it is 13,880. No, 13,080.
It's 13,000. Okay. Oh, it's 1,380, right? 1,080.
1,380.
Yeah. Okay. Okay. Great. So this is the mass of 500 bricks. Now, mass of pallet is given as 100 kilograms, right? Now they're saying that calculate the total mass of the pallet and 500 bricks. So we'll just add these two, right? This one and this one. So we'll just add these two, which would give me 1,480 kilograms. So that's the total mass of the pallet and 500 bricks altogether. So is that clear for everyone?
Yes, clear.
Okay, how about others?
Yes,
Yes.
clear.
Okay, great. Okay, so now, is it safe for the forklift to lift the total mass of the pallet and 500 bricks? So what it's really asking you is if it's safe for the forklift to lift a total mass of 1,480 kilograms. Now
Yes, sir,
remember,
because, yes, sir, because the forklift truck can lift to 2,000 kg, so it can easily lift 1,480.
exactly, right? Because 1,480 kilograms is less than 2,000 kilograms, and this 2,000 kilograms was the safe mass, right? So anything less than that would be also safe for the forklift to carry, and hence, of course, yes, it can lift safely all of this, all of the 500 bricks. So everyone agrees with that?
Yes.
Okay, good, great. All right, so now let's move on to this question, part B of the same thing. The brick shown in this figure has the same dimensions as the brick in that one. So dimensions meaning that it has the same height, same length, and same width, right? So this is the height, length, and width. So all of these dimensions are exactly the same as the previous brick, which was like this, except for the fact that now it is hollow in one face. So in top of it, it's hollow like this. So there is this thing, it's kind of, you can say it's like inside hollow, right? And it's made of the same material as well. If it's made of the same material as well, that means that the density would be the same. So complete the following sentences. The density of the brick in this figure 2.3 is dash the density of the brick in 2.1. So would it be, well, what would I say? Is it, has it increased, has it decreased, or is it still the same?
Teacher, is it less than?
Is it less? Why would you say it's less?
As it is hollow in one side of the face.
Okay, so you're saying, all right, now we're talking about density, right? Now, if you're talking about density and if it is made up of the same material, for example, you can say the brick is made up of, suppose it's made up of iron, just an example. We know that the density of iron is constant, right? Or any material's density will always be the same. So for example, if you're talking about iron, it would have a same density. Doesn't matter if it's hollow or if it's not, right? So
Yes, I understand now. I understand.
right, so if it's made up of the same material, as long as the material remains the same, then we can say that the density is going to also be the same, because density is just mass per unit volume. Now, of course, it depends on the mass and the volume, right? However, it is strongly dependent on the material, on the nature of the material, right? So the mass and volume will be adjusted accordingly. Now, in this case, the density is going to be the same, but as soon as we move to, actually, they're also asking you the reason, right? Because dash. So why would you say that the density is the same? It's same because it's made up of the same material, right?
Yes.
Right? Okay, so because this brick is also made of the same material. As the previous brick. Now, in the next one, they're saying that the mass of the brick in this figure is dash than the mass of the brick in the previous one. Now, what happens in terms of mass?
In terms of
What
mass,
would-
it is less than, as it's hollow in one side of the face. This is, I'm
Yeah.
100% sure this is right.
Right. Okay. Yes. So it is, the mass is less. And the reason now, if you want to think about it, you can think about it in terms of atoms or molecules again, right? Because of course, everything is made up of atoms. So if I have this many atoms, right? So these are the atoms that are packed together. Now, if I'm making the brick hollow from some part, so I'm just getting rid of some of the atoms. And now the brick is hollow because there are no more atoms of the material from whichever the brick is made up of. Now, if the atoms or molecules have been taken out of that place, that means that the mass, the amount of stuff has been taken out of the place. So when you take out something, so you're decreasing the amount of stuff, which means that you're decreasing the mass, right? And so, of course, then the mass would be less for a material that is hollow. So is that clear? I mean, if you have ever had a donut, there are different types of donuts, right? Some which are hollow from the middle, and then you have completely full packed donuts. I don't know if you have ever noticed this, but you can always feel the difference in the mass of both of the donuts, right? I don't know if you have ever thought about it, but the donut that
Yes.
is completely filled, yeah, it's slightly heavier compared to the donut that is hollow from the middle. Just an example. Okay, so is that
I
clear?
think
This all of,
it's slightly heavier.
yeah, sorry. Can you repeat?
The heaviness of the right, the heaviness of the not hollow donut is negligible, so I never felt it.
Right. Okay. Okay. All right. So for everyone, this thing is clear.
Yes.
Okay, great, great, good job.
Yes, sir.
So everyone is getting it, right? Okay, good. So let's move on to the final question. Question number 3. A ruler is used to measure the length of a piece of cotton as shown. Use this figure to find the length of one piece of cotton. So how would I find the length of this piece of cotton? Remember that the ruler, the cotton is not placed at a 0 of the ruler, which means that there is some 0 error in this reading. So you have to eliminate that 0 error. How do I find the length of this cotton? Anyone?
First, you can find the distance between 0 and the first part of the cotton, the left part of the cotton. Then you find the distance, total distance of the cotton, and then subtract both of these.
All right. So yeah, so you can exactly, that's what you can do. And the other way is also that if I find the maximum distance of this cotton, right? This one, which is this thing, if you look at this, and it's exactly the same thing as you said, right? So if I find this distance and this one, the two extreme distances, and I subtract both of them, then I'll get the length of the cotton, right? So for example, this one is 15.6. So that's 15.6 centimeters, right? And this one is 2.4 centimeters. Now just do the math, 15.6 minus 2.4 centimeters. So it's exactly what you just said, right? So this distance from 0 to this one is 2.4 centimeters, right? And the maximum distance from this to this point is 15.6. So just subtracting these two values, I'll get the length of the cotton. So just do the math, right? And what do you get?
That is
Can you tell me?
13.2.
13.2.
13.2 centimeters.
Right. So that's in centimeters, and that's the length of the cotton. So is that clear for everyone in the class?
Yes.
Okay, great. So, okay, we have 3
Yes.
minutes left. Let's try to finish this worksheet. So we just have some parts. Okay, so the left hand end of the cotton is moved to the 1 centimeter mark of the ruler. Now they're saying that if I take this cotton from this point, right, this one, and I move this to the 1 centimeter mark, which is this one. So now I am moving the cotton some distance to the left. So once I do that, how much distance to the left have I moved the cotton? I can just take this distance, which is what we have for this cotton, the distance that is to the left, which is 2.4. And then I'm moving it to 1 centimeter mark. So I want to see how much am I moving this cotton to the left so that it comes to the 1 centimeter mark. And that you can find by subtracting from 2.4 this 1 centimeter, right? So that would be 2.4 minus 1 centimeter, which is 1.4 centimeters. So what you're moving the cotton 1.4 centimeters to the left. So that means that the left end would be moving to the 1 centimeter mark. Now they're asking you that mark where the right end will reach on the ruler. So because the cotton is moving to the left, so if I can see at this point, the right end is at 15.6 centimeters. Now, right side is positive and left side, if I move to the left, then I'm doing, so I have to subtract something from it, right? So if I subtract the distance that I moved the cotton to the left from 15.6,
yes. You can subtract 15.6
exactly. So that
by
would give me
1.
exactly for 1.4, right? So that's 15.6 minus 1.4, and that would be 14.2, right? 14.2 centimeters. So the mark I should
yes.
put is on this one, right? On this side. So this is my mark, 14.2 centimeters. If I can get this right. Okay, right here.
Yes.
So the right end will be at this point. So is that clear for everyone else as well?
Why would it be 14.2?
Yes.
Okay, so it would be 14.2 because see, we're moving the cotton to the left, right? Now, if you're moving the cotton to the left, and they're saying that you take, you are moving it to the 1 centimeter mark. So if I'm moving the left end of the cotton, the left end